do is I want to talk about the definition of parallelograms, okay? So we have, in the name itself, parallelogram kind of gives it away, and hopefully you've already heard of and seen the definitions for parallelograms. So let's look to the left here. The definition of a parallelogram, like I said, the name gives it away. It is a quadrilateral with two pairs of parallel sides, okay? You see those little arrows, like right here, and then the double arrows here and here? That means parallel, okay? I'm going to put a little note there. The arrows mean parallel. So when you see that, that should tell you, oh, we are working with a parallelogram. So the definition's not hard. The next four things on the left are all the properties that you need to know, okay? They're theorems, but I want you just to think about them as properties of parallelograms that some of you might already know. So let's start with the first one here. In a parallelogram, the opposite sides are congruent. So either highlight or underline that right there. That is the first property we need to know about parallelograms. Opposite sides are congruent. So if BC is, let's say, 25, then I know that AD is how much? 25. Okay, very good. Okay, let me give you another one then. If I tell you that AB is 10, Joshua, what else do I know? If AB has a length of 10. Very good. DC is also going to be 10. All right, so most of you probably already knew that property. Okay, so that's not new. Opposite sides are equal, congruent. The next property, it's also really easy. It's our second property of parallelograms. It says the opposite angles are also congruent. Okay? The only thing you need to make sure you know here is, what do I mean by opposite angles? Okay? So for example, you can kind of tell by the coloring there. If angle A was, let's say, 70 degrees, then I know angle C is how much? 70 degrees. So A and C are my opposite angles, right? That make sense? Yeah? Yeah? Okay. If I told you that angle B was 110 degrees, then Tanya, what else do you know? Very good. D is also 110. Okay. Feeling okay about that one? Probably that one was not new. Opposite angles are congruent. All right. Next property, third one here. This one might be a little new, but it's actually pretty easy. It says the angles are supplementary. So we have to know what this word means, consecutive. If I say consecutive odd numbers, I'm talking about the odd numbers one right after the other. 1, 3, 5. When I say consecutive angles, I'm talking about the angles one right after the other. So angle A is consecutive to angle B. Angle B is consecutive to angle C, and so on and so on. So it's different from opposite. Opposite, guys, is going to be like across the parallelogram. That's opposite. Consecutive would be A and B, right? Right next to each other, not opposite each other. Okay? So the difference between those two is opposite are congruent, consecutive are supplementary, right? Okay, what does supplementary mean? Adds up to 180. Very good. So I'm going to put a little note there to remind myself it adds up to 180. So for example, if I said angle A was 60 degrees. Hans, can you help us out? How would we get angle B? Very good. Subtract 60 from 180, which would be 120. Does that make sense? These are supplementary. They're going to add up to 180 because they are consecutive, which means they're one right after the other. Okay? All right. Questions on that property? All you did is subtract from 180. Pretty easy, yeah? Okay. All right, last property. This one's so our fourth property here says the diagonals of a parallelogram bisect each other. So, first of all, the word diagonal, that means it's a segment that connects the opposite vertices. So BD is one diagonal, AC is another diagonal. And then we need to remind ourselves, what does bisect mean? We've heard that one over and over again. What does bisect mean? Remember? To cut in half, right? Cut in half. So for example, I'm just going to give you an example over here to the side. What if I told you BD is equal to 12? If I know that they bisect each other, what is the length of ZD and BZ? Anyone know? Or you want to guess? It would be half of 12, right? Because they cut each other in half. The word bisect means cut in half. So that means BZ would be 6, and so would ZD. If they give you the entire length of the diagonal, that was, in this case, that was BD, yes, you divide that by 2, right? 12 divided by 2 is 6, okay? If they give you, actually, let's make it more complicated. Let's do an algebra one. What if they tell you AZ is x plus 6 and ZC is 3x minus 10? Any ideas on how you would set up this equation? Exactly. 3x minus 10 equals x plus 6. We don't need to solve that because we're about to do a bunch of algebra practice anyway, but that's how you would set it up. Okay? And that's because if they bisect each other, it means each of those pieces are equal to each other. You see how 6 is equal to 6 right here? And then also AZ is equal to ZC. So bisect, think about it in two different ways. Bisect means to cut in half, but it also means it cuts it into 2 equal pieces. All right, 2 congruent pieces. Okay. So those are the 4 properties we are going to apply. They're not hard. You just have to know when do I apply which property. Okay? All right, let's practice that. Ready? Number 1, up here at the top. Here we go. In parallelogram CDEF, DE is 74. Let's label DE 74. DG is 31. And the measure of angle FCD is 42. So that's that whole angle C right there. I'm just going to put 42 out to the left of that. Find each measure. First one's pretty easy. First one we want to find is the length of C to F, right here. Okay, Victoria, can you help us out here? What do you think the length of CF has to be? .180 has to do with angles, so make sure you're not doing, since we're dealing with a side, not an angle, right? We're not going to use 180, okay? CF, what we know though is we know that DE is 74. So it would be what? How do you know it's 74? because it is across or opposite. Remember the property, the first one we talked about said opposite sides are equal or congruent. So therefore, CF is 74, same as the one across from it. Opposite sides are equal. Okay, pretty easy there, right? Oops. 74. Okay. Now let's talk about angles, okay? So now we're going to need to know that information when we're talking about 180 and everything. It's asking for the measure of angle EFC. So E to F to C, let me highlight that, is this entire angle F right there. We want to know what that whole angle is. The only angle that I know here is 42, angle C. I'm trying to find angle F. So I want you to think about it, be careful here. Are these two angles, C and F, are they opposite each other or are they consecutive to each other? What do you guys think? Consecutive? That's correct. If you're not sure, look at how I circled these examples. If you didn't circle them, I would go back and circle them for these. Opposite angles are, for example, A and C, across from each other. Consecutive angles are, for example, A and B, or A and D. So in this case, that was F and C are consecutive. Okay, so that helps me because I know that consecutive angles are what? Are they congruent or are they supplementary? They're supplementary, right? You don't have to memorize this. It's on your properties on the left. Okay. You do, however, need to know that supplementary means they add up to 180. All right. So if angle C is 42, how would I get the measure of angle F? Very good. 180 minus 42. Whoops. And that's going to give us 138 degrees. Okay. One more for this one. We have letter C asking us to find DF. I'm going to erase some of this. I already found that, so I'm going to, good there. Okay, what we need to find now is we need to find, actually, let's do this color, G to F right here. Okay. All right. So in order to find this piece inside of your parallelogram, you need to use the fourth property that we talked about. Look on the left of your note. Look down at the bottom left. The fourth property says the diagonals do each other, bisect each other, cut in half. Yes? Okay, so Sean, if this is 31, what do we know about GF? Also 31. Now, that's not what it's asking for, though. It's asking for the entire, should have highlighted the entire length there, D to F. So what are we going to do? Add them together. 31 plus 31, and that's going to give me 62 for my answer. Okay? Oh, I didn't write down the property here. You don't need to write down the properties, but it is helpful. Okay? Like in case you're going back and you're not sure how to do your homework. Diagonals bisect each other. Okay. So it's kind of a lot of properties, but like I said, they're not really difficult problems, especially these ones. These ones were pretty easy. We're going to make it slightly harder, just slightly, by adding in some algebra. Okay? Let's do it. Number 2. We have to find each measure here. This is a parallelogram again. YZ, the first one we're looking for, and the other one is the measure of angle Z. As you notice, we have some variables here, so we know we're going to have to do some algebra and solving. Okay? So I want to find YZ. I'm going to highlight that, which means I need to find the variable A. So I'm going to compare that up here. The only other side that has a variable A, right? So Mia, what do you notice? What do you know about those two sides of the parallelogram? They're congruent, right? You don't have to write this down each time, but I'm going to do it. Opposite sides are congruent, okay? What you do need to write down is the equation. So how would I write out my equation to solve for A here? Abby, can you help us out? Equal each other? Yeah, tell me what to write. Very good. 6A plus 10 equals 8A minus 4. And then solve. Would anyone like a calculator? You want to borrow a calculator? Use your favorite tool and solve? No? Got some hand sanitizer here. Might have your baggie. I'm out of baggies. No? Okay. Then you're going to have to do it by hand. Ready? And solve for A. Go. I'm going to give you 1 minute. Solve for A. Draw your line. Solve for A. I say plug it in. I'm saying you're replacing in front. Very good. Okay. And then figure out what that is. Check it out. So these all are different points here. If you're looking for the voltage sensor. Hold on. So I gave everyone both sides sheets. Right? So basically you're looking for which one is going to be voltage sensor. So based on the there it goes. Let's see how we did. All right, you may have done this slightly different, but check to see if you got the right final answer for A, and then when you plug it in. So I'm going to add 4 to both sides, but again, you might have done it a little different. That's okay. So I'm going to get 6A plus 14 equals 8A. Subtract both sides, 6 from both sides. 14 equals 2A. Divide by 2. So you should have gotten A is equal to 7, right? But then it's asking me to find YZ. So I go here to this 8A minus 4 and plug in your 7 for that. So if you haven't plugged it in yet after you got A is 7, go ahead and do that now with me. That's 8 times 7 is 56 minus 4. So that is 52. So there's our answer there. YZ is 52. Okay. Let's try this other one. Now I'm going to set this up for you and help you get started, and then you're going to finish it again. This is asking for the measure of angle Z. So that is our angle right here, which is 9B plus 2. The only other angle we have is W. Okay, so again, I want you to always check and ask yourself, are the angles opposite or consecutive? What do you guys think? Opposite or consecutive? Opposite? Opposite means they have to be across the parallelogram. Across the parallelogram would be over here. So these are actually consecutive, right? If you're not sure, remember, look over here to the left and kind of compare this. See how I circled the angles? Compare that to 2 and 3. 2 is opposite, right? 3 is consecutive. So to me, that looks more like consecutive, the third one, right? Okay, so why is that important? Because that tells me whether to set them equal or consecutive angles are supplementary. So instead of setting them equal to each other, you need to add them and set it equal to 180, favorite number, right? All right, so let's do that. 9b plus 2 plus, not equals, plus 18b minus 11, and then set that equal to 180. Make sense? Okay. You can either go straight into end solve right here, or you can solve it out. But if you're going to do this by hand, be really careful that your first step is to combine like terms. Everyone forgets that first step because we don't do it a lot. Like in the last example, I didn't have to combine any like terms before I started solving. This example, I have some like terms here on the left that I need to combine. Okay? So my like terms are 9 and 18. What's 9 plus 18? 27. So I'm going to write 27b. Okay. What are my other like terms? 2 and negative 11. Remember, you're not going to change the sign. You're just combining. Okay. So 2 minus 11 is negative 9. Bring down your equal sign and your 180. And then now I want you guys to finish this. When you're finished, plug it in to find the measure of angle Z. I'll come around and check. Okay. Solve for B. Plug it in to find angle Z. Okay. Do that. I'm going to check. Got it? All right. Looks like most of us got it. Okay, so you should have added 9 to both sides to get 189 equals 27b, and then divide both sides by 27. So I'm seeing b equals 7. I got another 7 there, but we're not done, right? Now we have to plug that in to find angle Z. 9 times 7 plus 2 is 63 plus 2, which is 65. Since it's an angle, I'm going to put a little degree symbol, and there you go. Okay? All right. Last one, ready for the last one? Last one, super duper easy, okay? Here we go. Let's finish this so we can finish our homework for tonight. Wouldn't that be awesome? Yes. All right. You have to use parallelogram, find each measure. First thing you notice, guys, this picture looks a lot like this last theorem on the bottom left, right? It's the only one out of all these properties that has the diagonals drawn. So when I see two diagonals drawn, you can automatically think, okay, we're solving for sides because there's no degrees, and we have diagonals. The only property that talks about diagonals is the last one there. Come on, stop that. So diagonals bisect each other. So remember when we talked about this a little while ago, we said that means it cuts it into two congruent pieces. Okay? So that means 4z minus 9 is equal to 2z. And separately, EJ, so 3w, is equal to w plus 8. Let's start with those w's. because it's asking us for JG first. So if I want to find this here, I need to find W by setting W plus 8 equal to what? Very good, equal to 3W. Okay, I'm going to draw my line. We're going to subtract W from both sides to get 8 equals, what's 3W minus W? 2W. And our last step is divide by 2. 8 divided by 2 is 4. But then I have to do what? Plug it into JG, which is W plus 8. So that's 4 plus 8. Actually, I'm going to write this out. JG is 4 plus 8, which is 12. Okay. Okay. If I went too fast there, make sure you're listening to the next one here. It's the same process. Okay, I'm going to explain it one more time. Ready? If they bisect each other, that's the fourth property. That means you set these pieces equal to each other. So this piece is equal to this piece. So our equation, exactly the same, but now we're doing 4z minus 9 equals 2z. Okay? Draw your line and solve. Let's do it. This one's a little different because you're going to get some negatives, but don't worry, they'll cancel out. So I'm going to do minus 4z, which is a negative 9 then equals negative 2z. Then I'm going to divide both sides by negative 2. What happens if I have a negative on the top and a negative on the bottom? Makes a positive. Good. Two negatives make a positive. So I get 9 over 2, which is 4.5 equals z. Okay. And then last thing. Okay, guys, real fast. Make sure you're listening here. It's asking me for FH. FH goes from here all the way to here, right? So what do I have to do? I know I have to plug it in, right? But then I'm not done. What do I have to do after I plug it in? Multiply by 2. Very good. So I'm going to plug it in here to 2z because that's the easier one. 2 times 4.5 is 9. So I know that one of these pieces is 9. What does the other piece have to be? 9. Could you plug in? Sure. But I know they're going to be the same. But I'm asking you for FH, the whole thing. So you either do 9 plus 9, or like Chris said, you can multiply that by 2 to get 18 for your entire FH. Okay, how do we feel about that? Not too bad? Hopefully. Okay. The only other thing you need to know on your homework, you might have a question that's asking you about something like this. So I'm just going to leave this on the board as you're working on your assignment in case you need help with that. If you have two diagonals like this and I give you the angles, let's call this 1, 2, 3, and 4. Angle 2 and angle 4 would be considered alternate interior angles. I know it's been a while since we talked about that, but it keeps coming back, right? Alternate interior angles are congruent. They are equal. So if I say angle 2 was 30 degrees, then angle 4 would also be 30 degrees. Also, angle 1 is another alternate interior with angle 3. Okay? So I just want you to keep that in mind. Alternate interior angles are equal. We didn't do any problems practicing that, but you do need to know it for your assignment. Okay? Okay, so I want you to go to Canvas right now.